Example 3 says, without graphing the term if each polynomial function has line symmetry about the y-axis, point symmetry about the origin, or neither. Verify your response. So I know that the examples that I gave you are not exactly the ones that I have here. Nevertheless, I think it should be enough for you to guide you in responding those questions. Let us just quickly review what an even function is, okay? So an even degree polynomial function is an even function if the exponent of each term of the equation is even. So let's look at this example first. First, we can see that it's an even degree function, right? The highest degree is 4 and it's an even degree. Is each exponent of each term, even? Yes. So this one is even, this one's even, and this one's even. And in case you didn't notice, how is it that the exponent of 5 is even? Because this can be written as 5 times x to the power of 0, which gives you 1, and 5 times 1. So it's the same thing. So basically, it's an even function. Even function, all exponents are even. Right, let's write this down. All exponents are even. And if all the exponents are even, then we know that it has a line symmetry about the y-axis. So it has a line symmetry about the y-axis. Okay, now on an even function this should be true. So I will leave it up to you to do it and to show me later on how that is true. Okay, so that means for every value of x, you're going to substitute negative x, and then you're going to expand, and then you should end up with that. Let's look at the next example. Even function or odd function? Well, an odd degree function is an odd function if each term on the equation has an odd exponent, and it satisfies this, right? So is each term here odd? Well, is the exponent of each term here odd? Well, this one is odd, yes, 5. This one is odd, 3, and this one is odd as well. And if you're not able to tell, well, that's to the power of 1. So all these are odd. So we know that this is an odd function. Odd function. And we know that all exponents are odd, right? Because all exponents are odd. All exponents are odd, and it has a symmetry about the origin. It has a point symmetry about the origin. Now, for an odd function, this should hold true. So once again, I'll leave it up to you to demonstrate to me how that is, and I will be checking it. Now let's look at the next example. What happens if you have a combination of odd and even, and then odd again, and then even? So what if it's odd and even? Well, we know that this is a odd degree function. However, it's not an odd function because all the exponents are not odd, and it's not an even function either because all the exponents are not even. So it's just an odd degree function, right? So it's neither. In this case, the question said either even function or odd function, or neither, so neither. And we can say some exponents are even, and others are odd. And of course, if you wanted to test one of these on this last one, it would not hold true. That could be a further support for that. If you have any questions, let me know, and don't forget to subscribe.